I'd like to show you the RiskVIew system and how it drives costs out of the network while raising customer satisfaction. In this radar diagram, we can see different portions of the network. Each dot represents a node serving 500 homes in a neighborhood. These all happen to be in what's called the Dallas metro area, and there's a maintenance person responsible for taking care of this area. The way the maintenance person decides what they need to work on next is by looking at which node is the furthest from the center. Furthest from the center indicates that's the area that's causing the most customer pain right now, as measured by the number of phone calls that have been received, truck rolls that have been rolled out to the neighborhood, repeat truck rolls, disconnects, and network telemetry data. The various inputs that are involved I've just described. If you go look at a larger area, for example, all of Texas, we've now got the Dallas metro area as one small portion, but you see we've also got Houston, Austin, San Antonio. In fact, the entire cable operator's network is represented on one page. Each of the dots in this case is a hub, and inside the hub there's several areas that need to be addressed. We can look at the Pecos hub, for example, and see that there's a couple of nodes that have outliers. We can go in to see those outliers, get the transactions. For example, see there's 163 transactions, and what those are in terms of connectivity calls, there's been 30. Trouble calls, there's been 4. Repeat trouble calls, there's also been 4. Disconnects and server assured data, for example, that's indicating modems in trouble from upstream and downstream errors. We can actually look at this by day and take those 163 transactions and then see how many there are per day. And so you see the calls have been coming in 1, 2, or 3 per day, but on this one day we had 10. This 10 corresponds to high levels of errors seen in server assure, and so we can see the correlation here. We didn't have to wait for the 10 calls. We could have seen the errors come earlier, which would have tipped us off to that there was something that needed to be repaired prior to us getting those calls. Likewise, the entire network can be viewed at once. In this case, where everything is, if you will, hiding under one dot. And now we've got every node in the network, of which there's about 3,700. We can sort them by reputational cost and see the most expensive node in the network, the next most expensive node in the network, etc. This list being 3,700 nodes long. And you can see then which one has the most connectivity calls, trouble calls, repeat trouble calls, escalations to maintenance, disconnects, and network telemetry data. Each of these is weighted to provide a single figure of merit, which gets us to the reputational cost, and that's how we put the worst node on top.